We're going to speak about the airfield design standards and operational safety, the why behind the standards. First of all, I would like to thank our sponsors for this session, the Scottsdale Airport and also Q&D Construction. When we assembled this session, we were given this choice of choosing a topic, and we decided to focus on the most popular FAA Advisor Circular, which is the 150-5300-13A, the airport design A.C.E. So the way we laid out the presentation or this session is this way. Our first speaker is going to go ahead and give you a general overview on the new A.C.E. and the changes. And the next two speakers are going to give you presentations on case studies on a couple of projects at different airports. And we have three great speakers lined up here. I'm not going to read their entire bio. The information is available on the conference app. I'll just give you a couple of sentences about each one. Our third speaker for today, this hour, is James Duke, who serves as the Western Region Aviation Sector and Vice President with 20+ years of experience in airfield engineering, aviation planning, and has worked at several large airports. Following him, before him, is going to be Ryan Sheelen, who works at San Jose International Airport. He's an aviation planner by profession and also a pilot. And also, we thought it'll be nice to have a representative from the airport owners perspective on this session. And the opening speaker for this afternoon is going to be Jeff Leonard from Mead & Hunt. He's the associate practice leader. He's going to give us a first session, and they are going to come give presentations, and we will hold the questions to the very end. And will you all please put your hands and welcome Jeff and rest of the team.
Thank you very much. So where we'd like to begin is just talking about, as Renju had said, about what really launched the 13A into the runway incursion mitigation program. Once the FAA finished with the RSA projects, the next thing they were investigating was the runway incursion and how we can mitigate that. So this was basically launched in June of 2013. The goal, of course, is to increase the safety for our airports. Essentially what they did was they prepared a preliminary RIM inventory report based on the runway incursion incidents, which included pilot, vehicle, and pedestrian deviations. What the report looked and sampled from 2008 up through 2015 was a number. So if you had 3 or more incursions in 1 year, or a total of 8 throughout the period, it was an area of the airfield that they wanted to look at and investigate further. And as they started compiling these lists, the study considered locations of geometry, pavement markings, signage, lighting, and where there's potential inconsistencies with FAA standards. So then after the FAA prepared their preliminary inventory report, they conducted field investigations, validations, and is now working with the airports to further look into the studies, design, and how to implement these fixes. Again, the geometry considerations are based in the report. There is a severity level from A through D based on the type of incursions and what those have resulted in. And then the FAA, there's a whole list of different, they're called geocodes. And I'll show you a few more examples on following slides. In any one area that is defined as a RIM project could fall into several of the various geocodes. So the taxiway configurations are most affected by the Advisory Circular 13A with the taxiway configuration offset that you see there. The overall goal is to offset the taxiways so you do not have direct access from the aprons of the runways, and also to simplify the taxiway intersections. Essentially, they want the pilot to be able to, or to require the pilot to turn before getting onto or to make an assertive effort and have to taxi and turn onto a new taxiway following a new connector in order to get onto the runway, just to prevent the pilot unawarely ending up in the runway environment. Another main focus of the 13A was to reduce the large, expansive pavement areas. The larger the piece of pavement, the further the markings are, whether it be the edge striping, the further out the lights are, the signage. So to reduce the pavement will also reduce the pilot confusion. And some example solutions are shown in this graphic here. You can simply remove the pavement, installing grass or just infield, or you can apply the green pavement markings. What we have found is more beneficial is a green slurry seal treatment. The problem with the green paint, or one of the concerns of the green paint, it fades fairly quickly just due to the low color of the pigment. Whereas a slurry seal, it's a homogeneous, it's a 1/4 inch thick. So as it continues to wear, you have a pretty good wearing surface there, and it does minimize the ongoing maintenance for the airport staff. And then the other main goal of the 13A and the RIM program is to limit intersection confusion, implementing a 3-node concept. Essentially what that means is if a pilot comes up to an intersection, he has 3 choices. Ideally it's straight ahead, left, or right. And as you can see in this graphic here, if you come up to that intersection right here, it's a generally confusing area. Next, talk a little bit about hotspots. So hotspots aren't specifically defined in the 13A, but what they really are is it's a location on the airport with a history of runway incursions where heightened attention by pilots is necessary. If you look on the airport facility directory, that's where the FAA identifies the different hotspots by number, and they'll have a description, as you can, a description on there of why that is a hotspot location. So some examples of the hotspot configurations that they're noting. The first one is where you have the high-speed exit, so you have multiple taxi lanes, large, vast, open pieces of pavement. And the second one, they're trying to promote the addition of islands there again, so you don't have the large, expansive pieces of pavement. The third graphic is illustrating where one taxiway crosses 2 runways. The goal is to make it very clear that the pilot knows what runway environment he's entering without the confusion of going on the wrong one. And then trying to remove the Y-shaped taxiways for the same reason, just to avoid pilot confusion and in simplifying access to and from the runway environment. Again, to avoid confusion and increase safety. So if you are on the list for a RIM project, the inventory list that's available from the FAA, I wanted to talk through a few of how to plan for these projects, or if you do have projects coming up that may be impacted as a result of the current mitigation efforts that the FAA is trying to implement. The main goal of it is to do a comprehensive analysis of the 5300-13A, identify all the potential areas of concern and non-standard configurations. And in addition, evaluate all the different elements, including air traffic control tower line of sight, taxiway naming conventions, as well as your future airport design groups and possibility for changes in the critical aircraft. Ultimately, just to ensure that your project is as streamlined as possible instead of getting down the road after the environmental and having to address changes. It's just not as efficient as looking at all these elements early on. And one of the most important things is the communication and the outreach. Early communication with your FAA planning program managers, your Part 139 inspector. I see Brian Armstrong is here. I'm sure he'd be excited to talk to you early on about these projects to make sure that you have the 139 inspector on board with your proposed marking, configuration, layout, signage, that it's a well-oiled machine early on to make sure you vet all those different options, and certainly bringing in the airlines, the air traffic control tower personnel, and airport users. It's all a necessity. It's all part of the same team. And to bring those folks on early, I'm sure several of you can attest, when you start talking with the pilots, they might look at a plan, look at a naming convention, and they're going to be the ones using it. So if they're confused during the discussions, there's a high probability they're going to be confused at the end of the project. So you want to make sure that what you're truly building is going to be beneficial and avoid the confusion that an existing configuration may have made. And then above all, develop and share realistic timelines. We all know that the environmental process can take some time. So beginning at the planning level through the environmental design and construction, that's an early part of the communication as well, just so everybody understands that these projects don't exactly happen overnight. And then there again, the main goal of the outreach is to prevent the improvements from creating an adverse effect after the fact or increasing pilot confusion. So once you get through the planning, the environmental, and the design, the implementation is obviously the final stepping stone and a key part. So developing a detailed construction safety and phasing plan, especially if you're doing taxiway renaming conventions, changing taxiway pavements, to make sure that the alternate taxi routes or the localized airfield pavement closures are well communicated with the airport users. That can be through a combination of social media, mailers, signage at the airport access gates. One recent project, they actually had 4x8 signs at every single gate that showed where the tenant entering the airfield was and the direction they need to go, and at every turn it was a well laid out plan, and yet that better? So this one time, so thanks. Sorry about that. So one other element that a lot of these changes has caused, or not caused, but the removal of pavement markings. So on an airfield, the pavement marking requirements change, or your airport design group changes requiring the markings. It has been, it's a challenge. With the new advisory circular, you have to remove the markings in a box type fashion. And so I just wanted to share a few lessons learned on that when you're trying to implement these new projects, is that when you do the marking removal, drum grinders work extremely well on non-grooved surfaces. Water blasting is also an option. But when you get on the grooved runway surfaces and you have to relocate markings, it is a very big challenge to be able to remove that marking effectively and not have that shadowing or ghost markings after, without having to replace the asphalt, which the water blasting really does a detriment to those grooves. And so talking with a few different folks around the country, I think the best solution that has come across is actually sandblasting. And then obviously it creates another cleanup measure, but the sandblasting is the only one that really gets into those grooves, into those pores within the asphalt. And then after you do the cleanup, of course, you go back and apply a fog seal treatment. But we are changing markings in the airfield environment. Just please make sure to do those checks. A good check is after the markings are gone. If you take a picture at night with a flash, you shouldn't be able to see any of the reflective beads or any of the shadowing. So that's a good little lesson learned to move forward as you're implementing these projects. Next, Ryan will be talking about the San Jose Airport. Thank you.
All right. Thanks, Jeff. Ryan Sheelen. I work at SJC. I'm an airport planner, so I'm going to talk about a few projects we've done that relate. And Jeff already said a lot of the stuff that's in my slides, so hopefully it's short. All right, so 2 airfield projects that we implemented as a result of 13A. So we have, we completed a Taxiway Alpha Bravo no taxi island on the south portion of the airfield, so I'm going to talk about that. And then I'm also going to talk about the signature taxiway connectors that we built up there on the northwest side of the field. So the Taxiway Alpha Bravo No Taxi Island. So this one actually originated while the advisory circular was being updated, so I cheated a little bit, but we're going to talk about it anyways. So it came up actually from our 139 inspector, and they cited 5340 1K at the time. Now it's been updated to 1L. But they also cited all those rim considerations, which I'm going to talk about a little bit as well, in the upcoming 13A. So it is very relevant. So in 5340, basically no taxi islands on taxiway entrances over 200 feet in width. That's something you really need to take a look at. So this one is an excellent example. Also, you know, as a result of that, you can put down more surface paint at hold shorts as well, but that really doesn't fix the problem when you have such a large piece of pavement. So 5300 13A rim consideration also talks about avoid large expanses of pavement, which Jeff mentioned in his presentation as well, and this one was over 500 feet wide, so it was an excellent project to move forward with, and this was only recently completed in 2015, well after 13A was updated and out there. So the operational issues that we did have with that piece of pavement was a lot of pilot confusion. As Renju mentioned at the beginning, I'm a pilot myself. I've worked out there in ops before. It's extremely confusing, especially at night when there's a lot going on out there, or even crossing runways, that type of stuff. So we had a lot of issues with GA pilots coming from the west side of the field, and you know, they get Alpha and Bravo confused because they're so close together and they're not necessarily paying attention. They might be crossing 30 left to depart on 30 right. So that's really the issue that we've had, is it's such a huge piece of pavement that pilots are just dumbfounded when they get out there. So an incursion that we had actually on the other side of it, the commercial side, happened during the construction of the project. So 30 right, which is in the bottom portion of the picture, we have two parallel runways, 30 left, 30 right. 30 right was closed during the construction, and an airline was running late, very late at night. They want to get out of the airport, so they're taxiing pretty fast. They're not necessarily paying attention, and they go to cross 30 right, actually at Alpha, and instead they crossed at Bravo. So they end up running over all the barricades for the closed runway and holding short, actually just right short of the construction area there. So that was an example where it was just, you know, they weren't paying attention, and it was a confusing area. So that's really a good example I wanted to mention. So this project, as I said, was completed the summer of 2015. Really resulted in a lot less confusion out there. We've had 0 incursions that have been reported, and you guys know how that goes, but it's a lot smoother since then. You can see in the bottom pictures before and after that it makes a huge difference. And we actually did do we just did the green paint down there, so not the best option, but you know, it makes a huge difference. So that was one example I wanted to mention. And kind of lessons learned, very, very basic. I think everybody here knows, pay attention to your A.C.Es and your A.C.E updates, just from that airport markings advisory circular and from the update to 13A. I think there's a lot that just our airport learned as well, and you know, staying on top of that and talk to the airports in your region, talk to your FAA inspector, and see what's coming up so you can stay ahead of the curve. Because this was an issue that we had for a long time and really didn't come about until a lot of those rim considerations came from 13A. Also, I want to mention we're in the middle of a rim study at SJC. So taking a look at other areas on the airfield where this also occurs, we have 2 areas we've already identified in the rim study, and that's Yankee Bravo, which is right across from where that project was on the south side, and also Lima, very, very large expanses of pavement, not necessarily as big as the Alpha Bravo portion, but areas that we want to look at. Could we do the same thing to that? So that was the first project example. Next, I'm going to talk about the signature taxiway connectors. some of these things Jeff mentioned, but this is really important because if you look at our airfield diagram, for those rim considerations that are in 13A, direct access is a huge issue on our airfield. It's the west side, the east side, it's pretty much everywhere. The only area where you see that it's not right now is obviously the signature over there on the west side that's just recently completed. So that was one of the considerations when we were designing those taxiway connectors, that we really wanted to make sure we avoided apron to runway. Also, that leads to increased visibility, those 90-degree intersection angles if you can, which we were able to achieve, and also increased pilot situational awareness, that 3-node concept Jeff mentioned as well. We're fortunate in this case where it's just 2 directions. You can go left or right. It's kind of hard to mess that up, you would think, but we're going to talk about that. All right, so the signature flight support connectors. We built 2 new connectors, again, northwest portion of the field. We designed them to the updated Airport Design Advisory Circular, 13A. They were completed about late 2015, and Signature, if I haven't mentioned that as well, Signature was brand new. That was the whole purpose of the project, so we were building the FBO. Signature opened in early 2016, right in time for the Super Bowl, which we hosted in February, and surprisingly, we didn't have too many issues. It went pretty smooth, so there's that good takeaway from that. However, with the connectors not being lined up to the current taxiways, you know, for a purpose, for direct access, which is going to be the issue in the next slide here. I wanted to mention that. And also the non-movement area boundary line and service road, just kind of the spacing and the depth of the ramp you can see in the bottom right picture. It's just really not there. It's kind of difficult. You have the service road just to the west of that non-movement area boundary line at the taxiway connectors. So there's not a whole lot of room for to put additional signage there, that type of stuff. So I'm going to talk about that in the next slide. All right, so the operational issues. Again, this is a good example. This is kind of what I'm getting at in these airport projects that we've done. Is basically we have aircraft taxiing to the FBOs or to the general aviation area from our 2 runways, 30 left or 30 right. Generally, they're getting instructions. They're coming off, exiting the runway, Gulf or Juliet, and then they're taking Victor to their final destination. However, a lot of times they're getting the direction to hold short of Gulf, and as you guys can see from the picture, that dashed line there is where Tower is wanting them to hold short, but there's no signage there, so they end up moving a bit forward to where that arrow is and blocking the signature entrance, and they actually hold short of Gulf right in front of the signature exit there. So you'll have an aircraft taxiing out of signature, and right, they can't go anywhere. So it leads to a problem. I mean, it seems like a very small problem if you guys are looking at the picture, and that's what you think as well, but we know that with air traffic control, these things can be very large problems. So basically, they also have that other exit over at Juliet, but I think everyone knows, you know, sometimes depending on who's in what hangar and what part of the ramp is operated by different folks, that they don't really use that exit at all, or it's frowned upon. So basically, what ends up happening, I'm gonna go to the next slide here. So what ends up happening is air traffic control, they just hold them on the ramp in their parking spot. Not an ideal scenario at all. They hold them in their parking spot, and essentially they have to wait for anyone exiting, coming off the runway, to get to their destination before they will release anybody off of that signature ramp to taxi to the runway. So not ideal at all. Again, it seems like something that could be easily mitigated, but we haven't had too much success so far with that. We've had a lot of ideas. One thing I wanna mention is that from 139 compliance side, and also meeting the design advisory circular, we're in compliance, but we're still having these issues. So brainstorming from folks in the airport department and with air traffic control. There's been a lot of ideas, but nothing that really has been able to fix that issue. So, you know, can you install additional signage? Where do you put it? The current Taxiway Gulf short sign is just adjacent to the taxiway there. So naturally the pilots are gonna hold short right adjacent to the signage. So where do you move the signage? Taxiway surface painted location markings. We already have some of those actually for Taxiway Whiskey and Whiskey 1, which are right directly under Taxiway Victor there, with Whiskey 1 being our closed third runway 1129. So we already have that out there. It's extra work. I mean, everybody here knows, you know, we don't want to put down more markings on the airfield if we don't have to. We have enough trouble keeping up with, you know, with our maintenance folks just to keep everything painted with what's out there. So that's not a really good option. And then you know, another option from that we get from the control tower coming back, and they're saying, well, put a different colored lead-in line to the taxiway, and we know that's never going to happen. So we don't really have a lot of really good options. However, we are in the middle of the rim study, as I mentioned. So there's a lot of good that could come out of that in the future, depending on who you talk to. So I just want to touch upon the rim study real quick. We're in the middle of the rim study right now. You know, we expect to have these alternatives out to our working group shortly. But, you know, as you can see from the history of incidents, we've had over 130 in the past 15 years for our study that we're taking a look at. And a lot of them are over in that west side area, not up at Signature, which we've been talking about because that was built recently. But there's been a lot of incidents, and when we're taking a look at the west side and the design aircraft over there, it's changed from Group 2 to Group 3. So, you know, we're essentially, we already have a modification to standard for when we were operating that former 1129. So when we're taking a look at the potential alternatives we can do on the west side, there's a lot that we could reconfigure, and whether that's reopening the runway and eliminating a taxiway, or closing the runway for good for safety reasons and bumping out the FBOs, I think regardless there's good chance that we will mitigate those taxiway connectors and the issues we've been having with that, especially through, you know, putting islands out there and getting those 90-degree turns and that type of stuff. So real quick, just 2 projects that we've done that are relevant to 13A. You know, we've had some struggles, but some good stuff's come out of it. So I will pass it along to James, and thank you.
Cool. Thank you, Ryan. So 5313A is new. It's 5 years old in the FAA world. I guess that's new. Some of the issues that 13A has brought up have become contentious for some of the airports. So we have a geometric case study of an anonymous airport. The names have been changed to protect the innocent and the not so innocent. So the project was basically a very straightforward taxiway reconstruction project. The taxiway has a non-standard taxiway object-free area. There's non-standard taxiway and runway separation. We've got a non-standard centerline geometry, and to complicate it, the runway operates under declared distances. This airport is actually a Part 139 airport. They fly Airplane Design Group 5 aircraft. We're looking at Taxiway Design Group 6, aircraft approach category D, and this airport has 3/4 mile visibility minimums. So that really defines from 13A what our geometric standards are going to have to be for this airport. So you can understand declared distances. I think most of the pilots understand declared distances. I think most of the airport managers understand declared distances. But basically, declared distances are when you have a runway safety area or a runway protection zone issue, an obstacle, you declare certain parts of the certain parts of the runway open, certain parts of the runway closed. At this particular airport, I've only got 8,900 feet of takeoff run available, and that's going to be very important later in the presentation. So this is the existing condition. Existing conditions are always black and white, right? They're never gray. So as it is right now, we've got a 450-foot wide taxiway, which really should be about 75 feet wide. We've got a fence line that's within 150 feet of the taxiway center line. That really needs to be 160 feet. And if you'll notice, the taxiway is angled. It's not 90 degrees. It's actually got an angle of about 34 degrees to the runway. And that results in the aircraft, the taxiway center line, becoming tangent to the runway center line, 337 feet from the end of the runway. So right off the bat, I've lost 337 feet off of my 8,900 foot of takeoff distance. When we go to the runway design matrix that's in the back of 5313A, we notice that the minimums for, or that the table for visibility minimums of not less than 3/4 of a mile requires a runway to taxiway separation of 400 feet. I will say that this airport is at an elevation of less than 1,345 feet. So we should have 400-foot runway to taxiway separation. In this case, we have 350 feet. Next, we look at the runway and taxiway intersection. How does that geometry work? So we want to use standard taxiway intersection angles whenever possible. The 3-node concept: straight, left, right, 30, 60, 90-degree turns. Non-standard intersection angles will require that you model the aircraft movement at that intersection. So we thought we had it all figured out, right? We're good planners, we're good engineers, we're good airfield operations folks. So what we did is we relocated the taxiway center line to have 160 feet from our fence line. So we've got a standard taxiway object-free area. We reduced the width of the taxiway in order to allow a turning movement. It's a little greater than 75 feet, but it's necessary for the turning movement. What we did do is we utilized a 150-foot radius and made the taxiway center line perpendicular to the runway to take advantage of a 90-degree angle, which allowed us to reduce the radius onto the runway to 115 feet. What does that give us? We lose 427 foot of takeoff distance. It's only 90 feet, right? Not too bad. But our runway and taxiway separation is non-standard. So based on our existing runway and taxiway separation, we would have non-standard dimensions identified in Table 4-12. The problem is, because we only have 350 foot of separation, we can only comply with the standard for taxiway design group 4. So we tried to get a 90-degree intersection, but it wasn't really practical because of the fence and an adjacent roadway. We looked at the taxiway intersection criteria, and anything that we do to improve the geometry of the taxiway negatively impacts our runway distance. So we fall to looking at aircraft-specific modeling. So what we were trying to do is evaluate the impact to the runway length available for takeoff when we modify the taxiway geometry. We're playing the best of worst cases. Wrong way. So when we do aircraft-specific modeling, the Advisory Circular 13A has very specific criteria that are used. We cannot have a maximum nose gear steering angle of greater than 50 degrees. We don't want to overstress the nose gear of the aircraft making the turn. We don't want differential braking, and we don't want differential thrust. Honestly, we did do a model that locked up the left differential braking. We did full thrust on one side, reverse thrust on the other, just to see what the aircraft would do. But we didn't share that because it was a little bit aggressive. And finally, the goal here is to minimize the impact of the runway for takeoff. So I want to run through the cases that we went through, and I'll summarize them at the end. But basically, when we look at Taxiway Alpha coming into runway 1331 with a Boeing 777-300R, we maxed out the turning radius on that aircraft. We made it as tight as we could. What does that do? That reduces our taxi speed to 3 miles per hour, maxes out the nose gear steering angle, loads up that nose gear, but what it also does is it increases the time it takes that aircraft to get onto the runway, which can potentially hold up your aircraft that are holding for the next departure. So we loosened it up a little bit. Let's increase the radius, let the aircraft enter at a higher rate of speed. What we do here is we end up with a 150-foot radius, but the nose of the aircraft, when it becomes tangent to the runway, is 755 feet from the end of the runway. We've lost over 500 more feet of available takeoff distance. We looked at the A350-900 as well. Again, we relaxed the radius, we let the aircraft do what it really wanted to do, but we also ended up with 612 feet of runway distance lost compared to the 337 that we had to start. But if you'll notice, Taxiway Alpha begins further to the right in the frame. Taxiway Zulu is a different story. I can't tell left from right today. So when we look at Taxiway Zulu inherently, because of the angle of the taxiway, the aircraft wants to enter the runway further to the left, which puts it further from the end of the runway. Again, we looked at a 767-400 ER at the request of Airfield Operations. We maxed it out. Let's push the aircraft as hard as we can. We ended up with a 97-foot radius, a 5-mile-per-hour taxi speed. The nose gears turn at 90% of its max angle, and we end up with almost 800 feet of lost runway. We looked at the 777-300ER. We let the aircraft do what it wanted to do. No reduced speeds. We've got a good nose gear angle, 150-foot radius, but we lose almost 1,000 feet of runway length. And then finally, we looked at the A350-900, very similar to the 777. We end up with 825 feet of lost runway length. So when we summarize the results of the modeling in the existing conditions, when you start to look at the takeoff, the distance of the start of the takeoff roll from the end of the runway, in all cases, our effective runway length is going to be reduced when we get the taxiway to a condition where it's going to meet the standard. For Taxiway Alpha, our worst case is an effective runway length of about 8,385 when compared to 8,900. Taxiway Zulu, the worst case is 8,165 feet. That's a loss of over 740 feet. So an operational change could be made to depart your Group 5 aircraft from Taxiway Alpha. What did we learn from the project? In this particular project, the design criteria are very highly intertwined. In this case, our runway and taxiway separation impacted our runway and taxiway intersection geometry. Because we didn't have a standard separation, we had to modify the intersection geometries. Our runway and taxiway intersection geometry then impacted our available runway length for takeoff, which materially affects the operation of the runway. And then finally, because it impacted the length of the runway, because of where the taxiways intersected the runway, there's the potential that this could actually impact the declared distances on that runway. So kind of to echo some of the things that Jeff had said, some of the key lessons learned is we need to engage our stakeholders. We need to engage them early. We want to identify the impacts to the airfield as early in the project as we can. That's going to include early engagement not only with airfield operations, but we also want to engage our carriers and our other users so that we can understand how the changes to the airfield are going to impact their operation and if there's anything that we can do to mitigate that. And Renju, I'm going to turn it back over to you, sir.
Thank you, James. Can we all give them a big round of applause for the great presentation? Thank you. We have a few minutes left for any questions and answers. If you can raise your hand, if any of you have any questions. Apparently you guys did a great job. I guess we're good. And once again, I would like to take the opportunity to thank our sponsors for this session, Scottsdale Airport and also Q&D Construction. And also thanks to Jeff, Ryan, and James. Thanks for your time and appreciate the presentation.